Hello, everyone. My name is Tegan Clary, and I head up the marketing team at Unchained Labs. I'll be your moderator today, and thanks for joining us. We will have a Q&A session at the end of the presentation. So if you have any questions, all you have to do is click on the Q&A button in the Zoom navigation bar. It should be at the bottom or top of your screen. Type in your question, hit submit, and we'll get to as many of them as we can. Please try to avoid clicking anonymous so we can reach out after the session if we're not able to get to one of your questions. And now I'd like to introduce Del Jackson, Senior Product Manager at Unchained Labs. Hey, Del, how are you today, man?
I'm fantastic. Thanks, Tegan.
Awesome. Del is going to talk to you about our newest product launch called Unagi. Unagi is the first completely hands-free benchtop buffer exchange platform that brings together all the painful but very critical steps that it takes to exchange a protein, an AAV, or other types of biologics or gene therapy products from one sample to another, or to concentrate them up into a working range so you can actually do other analytics or other things with them. I'm excited to hear your presentation today, Del. I'll hand it over to you now, and I hope everybody enjoys it. Again, please don't be shy. Ask us questions, put them in the chat. Okay, I'll see you at the end, Del.
Thank you very much, Tegan. Hi, everyone. I'm Del, as Tegan mentioned, here today to talk to you about Unagi as a total state of awareness and now buffer exchange. So you logged in today to learn about Unagi, but probably not this type of delicious sushi that you see on the screen. So why am I showing it to you? It's also not your Wordle clue for the day. Unagi is 5 letters, right? So not for Wordle today. It is a total state of awareness, but more importantly, it's also a solution for your buffer exchange needs. And what are those? Well, let's just have a quick discussion so you can see how what you might be experiencing in your lab will tie in today's talk. So buffer exchange is a very essential step for so many things. Tegan mentioned that we're talking about biologics and gene therapy molecules. So we can start with lipid nanoparticles, which are a very popular vector now. And if you produce these, you know the challenge or the necessity of taking those out of that organic solvent very quickly after manufacturing. For viral vectors, if you work with those, AAVs of various serotypes, often you can produce these in a large volume, but the concentration is probably not what you want. It's too dilute, so you need to concentrate those right after. If you work with nucleic acids, usually there's a downstream process where you want to analyze or quantify, characterize those in some way. Typically, you need to do a buffer exchange to desalt those before you can do that. And my personal favorite, with my background, proteins, antibodies, oftentimes once you even identify and discover your protein or monoclonal antibody, you need to find the optimal formulation. And so buffer exchange is a necessary step in doing that. And what ways do we do this in our labs? Well, if you're like most of us, you're still using manual methods. And a large reason is because these are quite accessible. And there are dialysis, centrifugation, and TFF. With dialysis, oftentimes what I hear from customers is that it is slow. I also recall this from my grad school days. It can take days before you can accomplish your buffer exchange. You also run the risk of diluting your sample, and there's no way to concentrate at the same time when you're doing buffer exchange using dialysis. With centrifugation, it's faster, but you can have some problems. For me personally, I didn't like having to be tied to the centrifuge throughout the day. I could buy a few moments while I was spinning my samples down to do buffer exchange, but I would often have to go back and then check on them and manually figure out how much new buffer to add. There's also the risk, especially with nucleic acids and proteins when you're using centrifugation for your buffer exchange, is that you can have sample loss because they have a tendency to gel or aggregate as they get spun down. And with TFF, it works great if you happen to have very large volumes of samples that you're running, but it can be complicated to both set up and tear down. So what is the better way? Well, now finally, drum roll, we're getting to our Unagi, which we're very happy to have just launched last week. And with Unagi, you're going to be able to do up to 8 exchanges and concentrations. And by 8, I mean you can run 8 different samples all at once you have a working volume range from 0.5 ml all the way up to 48 mils of sample that you can ultimately concentrate down. And the best part is really that you can set this up and have less than 15 minutes of hands-on time while you're doing your buffer exchanges and concentrations. The format that your samples are going to ride in when they're getting processed by Unagi is the UNA. You can see here that you can have up to 8 of them in this little sample rack. I like this sample rack because it makes it easy to set up your samples, to add them to the UNA at your bench, and then transport them over to Unagi when you're ready to start your runs. We use a 10 kilodalton molecular weight cutoff, and the filter material is regenerated cellulose, which is great because this has low reactivity for most biologics and gene therapy molecules. So how does this work? You load your samples up, and what happens next? Well, we have an automated pressure-based ultrafiltration and diafiltration technology. And this is really, as a product manager for buffer exchange, my favorite slide to share with customers because it shows very simply our innovative technology and the benefits of it. And so looking at your screen from left to right, once you have your samples in Unagi, again, you can have up to 8 of them. What Unagi is going to do is measure the volume initially. And this is a critical step because what it does is it allows Unagi to adapt the filtration cycle. And that filtration cycle is accomplished with positive pressure that's applied equally, evenly across all of your samples. While that's happening, you have optional mixing or gentle orbital mixing, which can increase your flow rate. And then at the end of every single buffer exchange cycle, we do another volume measurement. So Unagi is always going to know how much sample you have and how fast each one is flowing individually. And if there are differences in that, that's okay, because the refill or the addition of new buffer is done exactly to what was lost. So you have a perfect match between what was lost and what is replaced. At the end of the process, then you have your exchange samples. Well, the cool thing is that you can also concentrate them then as well. Unagi will do that for you, and that's an optional step. And speaking of concentration, you have options. And so you can concentrate beyond just that starting volume of 8 mils. You can actually take 48 mils of sample, again, up to 8 of them, and bring it all the way down to 500 microliters. We call this our reduced sample volume application, but really it's just a fancy name for an additional concentrate application where you can concentrate a higher starting volume. I mentioned that mixing, that it's one of the key parts of our buffer exchange technology. And what is so great about it? Well, you can see that with other techniques, you end up with what's called dead-end ultrafiltration. And what this is an aggregation of your biomolecules of interest at the membrane or the filter interface. And this is often what I hear from customers who are running centrifugation suffer from. And it's really the drawback of lower sample recovery, and sometimes it even can reduce their sample integrity as things like protein can change at higher concentrations. You won't have that on Unagi. With the optional gentle orbital mixing, we keep your solution, your biomolecules of interest in solution. And so they're spread throughout the entire UNA in that case. And the benefit of that is that it prevents clogging and gives you faster exchange, but also better results, which we'll see in a moment. One of the great things about Unagi also is that you can program exactly what you want. So no more are you going to have to eyeball how much filtrate was passed through and then try to pipette that exact amount in. You can just program that into Unagi, and it's pretty straightforward. So you can program percent removal. What this does is give you control over how much in each buffer exchange cycle, how much volume we're going to take out. Your final goal, the percent exchange, is also something that you program in. You want 92% or 96 or 99.9, you'll be able to enter that into Unagi. And because of that volume measurement, it's going to nail that target exchange value for you. And then, of course, the final concentration part. You've never entered in a concentration value into your centrifuge. You have to manually do it. Not so with Unagi. you're going to be able to program the exact concentration point that you want to have at the end. And everyone in the lab is going to use it. You can order up your molecules how you want it. We have already programmed in 32 presets for you. And these are based upon the molecule and the experiment type. And it's pretty straightforward what it changes for you. It changes the pressure and the target removal value. But all of these settings, including the mixing, are customizable. So we don't take that away from you. We just give you these nice presets. So if you want to come up and program quickly, you'll be able to do that. And speaking of, you can see here in these software screenshots that you'll be able to select your molecule and the concentration range, and then one of the 4 experiment types on the left. So that's a little bit about how you set up your Unagi, how you would enter things into the software. Let's peek inside, if you will, into the instrument itself, raise the lid, and here's what we see. So moving from left to right, on the left, we have a buffer rack. Here is where you can have up to 16 Falcon tubes. These are the 50 mil Falcon tubes. You'll have a buffer exchange chamber in the front. This is where all the magic happens. This is where that Una rack that we saw previously is placed and clicked in there. What you can't see is under there, that is where the orbital mixer is. There's a single 1 mil pipette channel that works with air displaced technology. To the right of that is the ultrasonic volume sensor, that key part, which we'll see in just a moment. And then we have tip racks for you on the right. So here you should be able to see Unagi in action at the beginning of a run. And again, at the beginning of every buffer exchange cycle, the ultrasonic sensor, that ultrasonic probe, is going to be used to measure the exact amount of sample volume that's there, so that we know exactly the percent exchange point to hit. So how good are these measurements? Well, you can look across the volume ranges that you can work with from 0.5 mil up to 8 mils, compare what we measure with gravimetric measurements, and you can see that they're in line. And also there's very high repeatability. So we have good precision and good accuracy with these ultrasonic volume measurements. And the thing that frees you up and lets you go off and do some data analysis or start another prep or maybe take a longer lunch break is that the buffer additions are done for you by Unagi. We pipette up to 1 mil at a time. That's typically adding new buffer back. But if we're running that reduced sample volume application, Unagi would be adding additional sample to each of your UNAs in the buffer exchange chamber. How good is it? Well, bang on, so to speak. So we have dispensed CVs across a wide range of volumes that are less than 1%. But the really cool thing, I have a background in liquid handling, and I love to see the results on the right there. There's actually 4 different solutions that were dispensed, and they vary in terms of viscosity. The reason why you only see single color is because they're all in line, so they lay on top of each other. What this means is for you, whether you're using new buffers or samples of different viscosities, you don't have to worry about the accuracy of your dispense, as we are so precise across a wide range of volumes as well as viscosities. So just super cool data there. And then finally, the key part is that shaking. You can see a little bit of it right there, but what's happening behind closed doors is that orbital mixing. It's part of the preset values, but also something you can program up to 1,000 RPMs. And it's not just the speed of the orbital mixing you can program. You can actually also program how often or what the duty ratio of the mixing is during the buffer exchange cycles. So you put all these pieces together, what comes out at the end? Well, really premium recovery. And so you can look, excuse me, if you look at our different applications working with protein here, so buffer exchange plus concentrate, or that reduced sample volume application, our recoveries are very high. And this also shows at the different concentration values for you. And I'll put in a shameless plug for our analytical products. We can do these in-house because we have both the Lunatic and Stunner platforms to very easily, in a label-free way, measure these concentrations. So that's protein. What about the other biomolecules that we mentioned? Well, I selected some of our initial launch data to share with you. And so for AAVs, LNPs, DNA, BSA, IgG, across, again, selected different volumes, you can see how well our final volume matches up, as well as the recoveries that we can expect. So while Unagi is doing the work for you, how are you going to keep track of what's going on? Well, in two ways. One is on the software that comes with Unagi. You can get a constant real-time display, not only of the entire run where you're at in your buffer exchange or your concentration cycle, but also you can set it up so, you can also see it per sample as well. So what you see here as a demonstration is that every single sample will let you know where it's at in its exchange cycle. This is nice because that pause button you see there gives you additional functionality where if some samples finish early, simply click pause, take those samples out, and then continue on your run. And also, most of us have a cell phone, so you can set it up so that Unagi will give you status updates in case anything happens during the run. But more importantly, you'll know exactly when your run finished, so you can go back and collect your samples and send them downstream. And all of this is tracked for you. All of this meaning what are the initial status of each sample, as well as the final results. Unagi will generate a report for you. And so you get individual sample results that you can print or export. So now you don't have to sit there and write down the individual results of every single sample. It's also going to track the processing results and give you a detailed report for even further data management or analysis if you need it. So how can you use Unagi? What problems do we help solve? Well, if you're working with monoclonal antibodies, Unagi is going to knock out your concentration, formulation, and cleanup needs. You can pair those nicely, as I already mentioned, with our stunner platform. So then you can also check concentration before and after and look for aggregation. And with our uncle, you're going to be able to do stability and aggregation measurements. Perhaps you're working in gene therapy, working with AAVs. So Unagi, again, is going to come in and be able to give you nice cleanup for your capsids, perform your buffer exchange and concentration. Again, you might make a lot of AAVs, but you need to concentrate it down. Then you can put those on the stunner to measure the capsid titer, the empty full ratio, look at aggregation. And of course, with good old uncle there, then they look beautiful next to each other, of course. Just imagine how they'd look there in your lab. You can check for capsid stability and overall stability of your AAVs. So hopefully today teased you enough so that you want to catch Unagi, have it in your lab, something everyone will be able to use to achieve fast and flexible exchanges. You're going to have that full process control. Something that I really appreciate and hear from a lot of customers is that they also want to have low hands-on time, but none of that comes at the cost of your sample recovery or sample integrity. So Unagi really is a delicious complement to the work that you're already doing for buffer exchange and concentration. And that is all I have to share with you today.
Hey, Del, thanks for that. Thanks for taking us through that. Just to summarize, Unagi really saves time by doing the entire process of buffer exchange and sample concentration, which is highly unique, right? There's no other system that truly does this from end to end. Other than our big Tuna, and there's a question about that, which we'll get to. It improves sample recovery. I know many of us who have done buffer exchange and concentration steps, it's hard to get high recovery. This instrument really does get greater than 96% recovery, which is awesome. And frankly, this system can help you stay informed with knowing when things are done, frankly, monitoring what's going on. And then, Del, you touched on it, but the reporting and tracking of every single step that it took is on a piece of paper if you need it to go into a lab book or into a LIMS. And I think I don't want to underestimate how important that is for people that have to really track down and monitor their entire process. So it's a big advantage. We have a ton of questions, so we're going to hit on as many of them as we can here. So let's go ahead and get to that. Okay, Del?
I love it. That's my favorite part of the seminar.
Yeah, and I appreciate all the questions. Keep them coming. Keep coming. So I'm not even caught up with them yet. Del, molecular weight cutoffs. You mentioned 10 kilodalton. Are there others on the Unagi system right now, or is it just 10?
We just have 10 at launch, and that's a good size because as you saw in that one slide, we can get good results with AAVs, LNPs, proteins, and DNAs using that.
Okay, great. And then in one of the videos, it showed the inside of the system. There's a question: why are there 16 sample buffer tubes but only 8 samples?
Yeah, I should have probably explained that. Apologies. So it's because for some of your runs, you might require more than 48 mils of buffer. And so that gives you up to 96 mils of buffer that you can use. And also keep in mind that those additional spots in the reduced sample volume application can be used for additional sample. So we have a 2-to-1 ratio, if you will, of buffer tubes to each Una sample.
Okay, thanks, Del. And then on the inside of the system, what happens if it runs out of tips? Does it track tip usage? How does it handle tips?
Yeah, so love to show anybody if they want to see a software demo later, we can coordinate that. But essentially 2 things. One, we do track sample usage. And so from run to run, Unagi will say, hey, this, as far as I know, this is where the samples were left. But it's really cool in the software, really with just like one click, you can show exactly, how many tips are left. So you don't have to have a full tip rack with your Unagi runs.
And Del, for running the system, what are some of the facilities required? Somebody asked if they don't have air hookups, what would they do?
So we have tested, and you can actually use a compressor for Unagi. And so we have specifications which would be required, but it does require air. We do, by what we use in our own lab is a hookup to clean air. You can also run nitrogen if you wanted to through Unagi. That's an option, but a compressor could also be an option if you just really can't find an air hookup in your lab.
Another one just on the inside and what's going on. Can the positive pressure be individually applied across each of the Unas, or does it apply it across all of the samples at the same time?
It's across all of the samples uniformly. So
Okay.
it's not individualized, which is another key part of, or key necessity of that volume sensor, because even though flow rates might change as a consequence of differences in sample concentrations or viscosities, Unagi will keep track of that. So if you're worried about like losing sample, it's not a concern with Unagi. We apply that even pressure, and then we adapt it, if you will, to the fastest flowing sample.
Okay. Great. There are a couple of questions in here. I'll answer this one. We don't talk about pricing specifically in our seminars, but if you would like to know what the price is or talk to us in more detail, also there's a question in here about demos. We will definitely do demos. We're really good at virtual demos. We would actually prefer that, especially with what's going on in the world. But if you need to have a system come into the lab, we can work that out. And that's something you would work on with our sales specialist team and our FAS team. So, we'll get in touch with you, or you can get in touch with us. We'll talk about that at the end, but we're happy to talk about the system, help you understand how it could solve some problems for you, and do a demo in either a virtual or in-person setting. Okay, so I'll leave that at that. Del, a couple more questions on the technical side. So here's one about starting volumes. If you start with a 0.5 ml, are you able to concentrate below that to a volume of below a 0.5 ml in a concentration measurement?
No, that is your working volume range. Now, that doesn't mean that at times in a buffer exchange cycle, we might exceed those volume ranges, but in terms of your starting or your final volumes, that is the working volume range. And we do that to, minimize the effects of dead volume and make sure that during orbital mixing, everything's staying where it should.
Okay, great. Let's go ahead and hit this one. There's been about four questions. So some people are obviously aware of our big Tuna buffer exchange platform. Talk a little bit about the differences. I think what people are asking is, what is the major difference between them? Are they using a different technology, or is it the same technology? What's the major difference that you could tell them about big Tuna and Unagi?
I really do love this question, because as a product manager, it's very exciting to be able to take what we've already been successful with, which is our innovative buffer exchange technology. I won't go into the details, but we had great success with that big Tuna, a lot of happy customers, many repeat customers. But what we saw is that there was a capacity that big Tuna wasn't necessarily suited for. And so the difference between the two is really just your capacity and your automation needs. So with Big Tuna, typically if you're running, more samples, and I don't want the term high throughput to throw you off, perhaps you're working like, 16 samples at a time or 20, but you can go all the way up to 96 on Big Tuna. With Unagi, it's at a different sample number. So capacity is one. The other one is automation. If you're working in a lab where you have upstream or downstream automation and you want to, pass samples to and from your buffer exchange solution, Big Tuna is a better fit there.
There are a couple of questions about the instrument itself. I'll go back over to the instrument and the UNAs, Del. Are the UNAs single use?
They are single use. Yep. And yeah, it's similar with Big Tuna. That's going to guarantee that you have, consistent results each time. So if you were to try to use it, we don't guarantee the results. But also you can have the peace of mind knowing that every single UNA has already been tested in manufacturing. And so your precious gene therapy, samples that you're adding to it, you have peace of mind knowing that nothing's going to go wrong when you run it on Unagi.
Okay, and then two questions you get asked often, Del, about our buffer exchange platform. So the first one is, is the chamber cooled and/or can it go into a cold room?
It is not chilled, and the reason for that is largely because the technology that we use is really dependent upon flow rate, and flow rate is affected by the viscosity of your solution. Temperature can have a big impact on that viscosity. So were we to do buffer exchange while it's cold, it would take longer. It would flow extremely slow. And usually, oftentimes customers ask this question because they think like, well, I have a rotor for my centrifuge. I know when I put it in the centrifuge, I type a temperature button. But what you should be aware of is that usually that temperature is to offset the heat that's generated by spinning your rotors very quick. So the actual temperature that your buffer exchange might be occurring at is not really what the number is you see there. If you put it in a cold room, that's not something we've tested. We definitely don't recommend it. But once you buy the Unagi, you could do what you want. But we haven't tested it for that. Putting it in a cold room, you can create other problems. But in the end, because of the speed with that gentle orbital mixing, and we saw this on Big Tuna, it's a question I get a lot as the Big Tuna product manager as well. But typically, your biomolecules are going to be stable enough for the small amount of time that they're, at room temperature while we do buffer exchange.
And Del, there's two questions about a rough estimate, and I know this is going to be sample dependent, concentration dependent, but to get to 96% recovery, and from some of the experiments you've seen, typically what's a runtime look like for somebody using Unagi to do a buffer exchange or a concentration?
Yeah, so anywhere between 1 to 6 hours, I would say, rule of thumb. Tegan's absolutely right in that, the concentration, the overall viscosity of your solution is what's going to determine your runtime results. That's a good rule of thumb. We do have additional data because it's the same technology on Big Tuna that we can share with you that allows you to correlate your sample viscosity to known protein concentrations to give you even a little bit better idea of how long you can expect on your runs. But something I always like to say is it almost doesn't matter because you're not having to sit there and babysit it. You push a button, you walk away, you can go do your meetings, do other sample preps, or do some data analysis.
Great. And then another question about samples, Del. We've dealt with a bunch of different kinds of samples, but I think there's a few questions about the maximum or kind of range of viscosity that we believe Unagi can handle. And I know we have some experience with that also with Big Tuna. But what viscosity typically can the system handle?
So I can't give it to you in a value of centipoise. I apologize for that. But to give you an idea, if you're familiar with working with proteins, 200 mg per mil, which is quite viscous. And we've run glycerol percentages, very high up to 60%. Now, it is slower as you get to the really viscous solutions. And so can we process it? Yeah, it just might take a little bit longer if you're starting your samples in a really viscous, thick solution.
Okay, last question, and then I know we're going to miss some, so we're going to have to follow up with folks. So I apologize for that now. But what is the footprint of this instrument? Is it big? Is it small? Would it fit in a hood on a bench? how would you describe the size of it?
Definitely capable of fitting in a hood, a good size hood. I would say it's about, I would say 1 meter by 1 meter roughly. If you're familiar with our Uncle instrument, it has roughly the same footprint. So absolutely a bench top. You'll be able to find room in your lab for it to sit on the bench. It's even, not that I encourage you to pick up your Unagis, but it's something you can practically pick up yourself. So nice, small, compact instrument. And one of the reasons we love it is because, it's that you're going to get the same benefits as you would with the buffer exchange technology we have on Big Tuna. Now it's just going to sit in a small part of your lab bench.
All right, great. Well, again, sorry for those of you we can't get to the question. We booked 30 minutes. We want to be respectful of people's time. Del, thanks for asking or answering as many of those questions as you could. If any of you on today want to follow up with us and get your questions asked that I couldn't get to, we'd be happy to do that. You can reach out to us at info@unchainedlabs.com, or you can go on our website, dig into it a little bit more yourselves, and you can just fill out any one of the kind of, hey, I want to speak to somebody from any of our pages on our website. So we'd love to connect with you. And then just lastly, we are happy to connect you with one of our sales specialists and field application scientists to talk about your specific workflow, the molecules or samples you're dealing with, how this might work best for you. And be happy to work on a plan to actually look at the instrument and do a demo if it makes sense for you and it's solving your problem. So we'd love to connect with you. Please reach out. Thank you again for attending our virtual seminar, and we appreciate your time, and I hope you have a great rest of the day. Thank you.